Hello, I'm Jason Daniels. I teach fifth grade at California Beach Elementary in the Kenai School District. And I'd like to share with you a grades 3 through 5 science lesson on humidity and precipitation. The science standards for Alaska were developed as a student-centered approach to science instruction to engage students and facilitate educators to engage in a new way of looking at science in their classrooms. They're based on the framework for K-12 science education published by the National Academies Press. And the objectives today are going to be to share some science resources with you, to talk about what a phenomenon is in science education, to demonstrate a three-dimensional science lesson, and to give you some formative assessment ideas for teaching science. Now I'm going to move through fairly quickly. How about a little weather humor? I'm going to move fairly quickly through it, but pause and rewind as needed. So I'm ready to teach about weather and climate, or maybe the students are asking questions about weather and climate. This could be a good time to pivot my science instruction. Here we see the third grade weather and climate standards. I also want to point out that if you're a fourth or fifth grade teacher, this process is going to look very similar to you. And because fourth grade covers weathering and erosion, and fifth grade covers earth systems and how they interact, so the hydrosphere is involved. These grade levels standards build on each other as students gain more and more understanding of weather and its effects on earth systems. So let's take a look at these third grade standards. The first one says, represent data in tables and graphical displays to describe typical weather conditions expected during a particular season. Just note that there are some clarification statements and some assessment boundaries, like we're going to be limited to pictographs and bar graphs, and it doesn't include climate change. And the second standard here says that we're going to collect some information to describe climates from around the world. And the third standard, I want you to notice it's got an asterisk there. The Science Standards of Alaska have placed asterisks there when the standard has to do with engineering technology and the applications of science. So this one says, make a claim about the merit of a design solution that reduces the impacts of a weather-related hazard like flooding. I found these standards on the Alaska Department of Ed Science Standards of Alaska website. And I am always thinking, using my Alaska lens, on how I can accomplish these standards in making it relevant and meaningful for our special and unique Alaskan students, wherever they are, villages, cities, and in between. So I have some science resources here for lessons that can be adapted into three-dimensional science lessons. So these are some places to look, not an exhaustive list. Some of these have vetted lessons in them, and some of them you would have to align them to our Science Standards of Alaska on your own. Let's take a look at NGSS at NSTA. So I did a quick search for weather-related lessons, and I came across an introduction to weather. And bonus, it is a unit. So I can pick and choose what I need from there. You can print or download using this link here, but I want you to make sure, if you're using this website, to look down here at the 3 dimensions of science education to make sure that these are covered in the lesson. And so this website does a nice job of making sure that those are all covered by making notes about it. So when you're thinking about, just a quick refresher on the 3 dimensions, when you think about the 3 dimensions of science teaching, it's kind of like a book. The disciplinary core ideas are like the chapters of the book, the content. The cross-cutting concepts are like the themes you find throughout the book. And the science and engineering practices are all the actions and the skills you use to read and understand the book. So for the sake of time in our lesson today, we'll skip ahead in the weather unit. Let's say we've taught an introduction to weather and climate. We've taught about the water cycle. We've covered the different types and how much water is on our planet. And we are now ready to talk about humidity and precipitation. So I want you to notice that there's a standard that's covered here is ESS 6. Well, you probably figured out there is no ESS 6 in our science standards of Alaska. So whenever you're using these resources online to find lessons, make sure that you take note of this and make sure that you can align them or transform them to cover our science standards. Usually all it is just a little tweak, and sometimes it's no tweak at all. It's the similar standard, but it's something to be aware of. So let's talk a little bit about phenomena and problems. So when you're thinking, a phenomenon is usually a naturally occurring event in our world. And problems oftentimes are human-made problems in our world to solve. Whatever the case, they should always be something that students can observe themselves or model or measure, and in this case with weather, predict. They should be connected to a performance expectation like the ones we looked at earlier. They can really do a good job of anchoring and driving three-dimensional learning throughout the study. And they tend to focus, phenomena tend to focus on the science side. Problems usually focus on the engineering side. Well, so where do you find them? Okay, well, a great way to find phenomena is to look around the school. You might be surprised what you can find in the classroom or on the playground. Even the kids can find them. That's even better when they find them. You might hear them say, "Why can I see my breath when it's cold?" Or, "Why is there fog on the playground?" We try to look for local connections when possible, while at the same time comparing and contrasting globally. Of course, we can go local, community, region, state, national, and then global as well. We may have personal stories of bad weather, cultural connections, like good or bad weather for hunting, ancestral ways of predicting the weather, lots of different ways to find phenomena. They could even be teachable moments. I was on a trip to Homer not long ago, and I saw this odd weather phenomenon happening. I took a couple shots with my phone because I knew I could always bring it back to class when we're covering weather and have a good discussion about it. And then in a pinch, you can always use photos from the internet. You can also take the other side of this and remember that third standard about a design solution for a weather-related hazard, and I was bringing up flooding. So this could be a real fun engineering problem for the students to solve and evaluate. So after observing phenomenon, discussing them, students think of questions. So once the class has generated lots of questions, wonder walls are a great way to keep track of them. Post them in your class throughout your study. Use them to create a storyline. A storyline's like a progression of questions as students ask a question and then answer it. It might spawn new questions, and then we look to try to answer those. And it's a progression of learning through questioning. We refer back to them often, kind of come back to that anchor or that essential question. Check them off when students can understand, can demonstrate their understanding of them. So these questions can guide your lessons and student understanding about the phenomenon. Now, some questions can't be answered. You always have those kids that ask a question, it can't really be answered. But actually, this is just an example of real science anyway. So let's get to the fun part. It's time to teach. Now, videos are a great way to show phenomenon also, or to explain phenomena. Some videos are structured in such a way that you can show the introduction or phenomenon and then pause for your lesson or investigation, and then show the rest of the video explanation at the end of your learning. It's a way to kind of bookend a lesson. So here is our lesson on humidity and precipitation. Our essential question is a really good one. We want to make sure that we're covering the science concepts, but relate them to their own lives. So we'll come back to this at the end. Here is our standard, and in this case, I looked it up, and this standard is pretty much the same as our state standard, so we should be good to go on trying to transform this to our own standards. One of the first things I want to do with the students when we're beginning the lesson is kind of probe their prior knowledge, see what they already know, what concepts that might come up that are misconceptions. I'm always kind of trying to note those as we go. I'm going to cover the vocabulary when toward the beginning, the words like humidity, saturation, and maybe even water vapor. And then I can go a couple different ways with this. One of them is sort of straightforward way. I might give them, read to them an informational passage related to the topic. But also kind of a fun, different way to do it too is to get the students into their groups and then give them their tools, the model that they're going to use, and then ask them, how are we going to use these materials to learn about humidity and precipitation, and then just let them discuss with their groups how we're going to use those. And I'm circulating, I'm walking around, I'm listening to their discussions, and then I can give them a couple minutes there to tell me what they think we're going to do with them. But then it's time to get to work, so I'll introduce the concept of humidity to the class. Let them know that that's the amount of water vapor or moisture in the air. And then I might ask them, so where does that water come from? And hopefully they'll recall our water cycle lesson to be able to answer that question. And then I'll have the kids in the groups. Before the experiment, I'm going to ask them to squeeze the sponges to see that there's no water in them. And I'm going to ask them how much the water is in the sponge. Then I want them to make predictions in their science journals. I love science journals. I use them for all of our science learning. It's a way for them to record their information. I can give them information for them to use during a lesson. It's a way for me to see any misconceptions. I really like the science journal idea for science instruction. So predict what's going to happen when they add water to the sponge. And then the students are going to take turns taking the pipets of water and pouring them onto the sponge. I'm going to have them record their information in a table that I provided for them as they go. I want them to record or write down their observations as well. I might stop the class and give them a moment to do that because they don't tend to want to do that naturally. So we might just give them a chance to write something down and then let them get back to work. And I'm asking the students, what's happening to the water? What's going to happen when you keep adding water? We get into that saturation concept. Now, if I'm getting an understanding that they're not getting that, I might stop the class and give them a little mini lesson on saturation, and then we get back to work. And then at the end, we ask the groups to share their predictions and their results with the class. And I might do a full class bar graph, since that's in our standard, of all their results together. We can do a little bar graph or pictograph of that, which helps to accomplish that standard as well. And in the closure, I'll ask them some intentional questions to make sure we're getting at that phenomena or getting at some of those questions that they asked in their Wonderwall. I want to also come back to that essential question again. I'm going to ask that one here at the very end. So I might ask, how does humidity or precipitation affect your daily life, and take some answers with that. I just want to make sure that you understand how the 3 dimensions were used in this lesson. They recorded observations and data in a table. They analyzed and interpreted their data. And then here, one of my science teaching mentors explained to me how I can integrate the cross-cutting concepts in my science lessons. And I'm like, duh, I should have thought of that. But she just said, take the cross-cutting concept and turn it into a question and ask that question in your lesson. Here is a sample student recording from one of the groups. And it's important to address misconceptions throughout our science lessons. For instance, clouds versus sponge, the difference, condensation versus absorption, the saturation concept. And then here's a question I like to use when we're using models in science, is that how is this model the same and different from, in this case, how clouds and precipitation form? But you could use that question, just slip in whatever topic you're working with. These are some sample assessments. By no means is this exhaustive, but there's some ideas to go with on your science and engineering ideas that you're working on. They should elicit sense-making from the phenomenon or problem-solving with the engineering topics. And they should support a claim with evidence. Observational or group work could also be a form of assessment. And a culminating project could use multiple skills in one project. My go-to is Science Notebook for most projects that we work with. They should be driven by meaningful and engaging scenarios. I particularly use scenarios with my engineering projects. It allows me to make it local and relevant to the kids. And they should be designed to elicit three-dimensional responses. In this case, with our humidity and precipitation lesson, the students should be able to create a bar graph of the data. They should be able to analyze it, and they should be able to make predictions about it. If you made it this far in the video, thank you very much for watching. I hope you got some ideas from it. Here are some resources I used for the video. And this is my contact information. Feel free to contact me anytime. Talk about science teaching. And thank you for watching. Please visit the Department of Education and Early Development Standards webpage at this link.